So now we're going to move on to ones that are just like a little bit different. They might involve some factoring or some solving. And to make that a bit easier, what I'm also going to do is ask these questions. So it'll say solve finding all solutions in this domain. So it'll say from 0 to 2 pi or from 0 to 360 degrees. Now you will notice that there's a square bracket on 0 and a round bracket on 2 pi. It's because if you think about a graph, like if I were to graph a sine graph, the answer at 0 is the exact same as the answer at 2 pi or 360 degrees. So they only include one of them. So like, okay, round bracket, and we'll do square bracket to there. And the textbook loves or. Maybe because they're just like, hey, what do you like? I don't know. Maybe just try both or pick some of the questions and do some in radians and do some in degrees. Most people are more comfortable in degrees, so maybe push yourself to answer in radians because when you get to upper levels, radians are actually way more useful and used. All right, so saying that, the questions will look similar, except instead of having 2 sine x minus 1 equals 0, I've got 2 sine squared x minus 1 equals 0. Well, what does that look like? Well, step number 1, isolate your trig function. So I'm going to add 1 to each side. I end up with 2 sine squared x is equal to 1. I guess I should show that. And then I'm going to divide by 2, and I end up with sine squared x is equal to 1/2. Then I don't want sine squared x, I want just sine x. So on the inverse operation of squaring is square rooting. So I'm going to take the square root of both sides. Now don't forget, when you take the square root, there's 2 answers, a plus and a minus, and that very much matters. So you would get that sine x equals plus or minus. Now I'm going to write this as a quotient of 2 radicals. So the square root of 1 over the square root of 2. And the square root of 1 is 1. So it's plus or minus 1 over root 2. Then we draw our special triangle. Okay, but this time it wants all the answers. It wants where sine is positive and where sine is negative. So my answers are going to be in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. All right, well, what's the angle? Well, the opposite is 1. The hypotenuse is root 2. So that makes it my 1, 1, root 2 triangle. So in every single one of these, my reference angle will be 45 degrees or pi by 4. So now all you're doing is you don't have to write a general equation. You're just listing all the answers. So between 0 and 2 pi, so between 0 and 2 pi, my answers would be pi by 4. 1 less than 4 pi by 4, so 3 pi by 4. 1 pi by 4 more than 4 pi by 4, so 5 pi by 4. And 1 pi by 4 less than 2 pi, which is 8 pi by 4, so 7 pi by 4. If you need a review of that, I'm more than happy to help out. And then we could answer as well in 360 degrees, because why not say or? I can't do one, like when they put it, I'm like, I have to do both. But it would be 45 degrees and then 180 minus 45. I think it's 130. I should have done that enough that I'd know. Yes, 135. And then 180 plus 45, which is 225. And then 360 minus 45, which is 315 degrees. Those are all my solutions in the given domain. All right, so I want you to do this one, but before you pause the video, I want to make sure that you're okay with the fact that this is secant. If you feel good, pause the video now and go for it. If you're like, ugh, secant, just keep watching for like another minute. So what do you do to solve a trigonometric equation? First thing you do is you isolate the trig function. So I'm going to add 4 to both sides. I end up with secant squared x is equal to 4. Then the opposite of squaring is square rooting. So I'm going to take the square root of both sides. I need that plus minus. In fact, I'm going to write it in red so that we don't forget about it. So plus and minus. And then I'm going to take the square root. So I end up with secant x is equal to the square root of 4, which is 2. Now, if secant x is equal to 2, and secant x is the reciprocal of cos x, then I could say that cos x is equal to 1/2. Now, if that's too big of a jump for you, okay, put in a middle step. Put in something along the lines of secant x is 1 over cos x, which equals 2, and then you could multiply cos x and then divide by 2, and you end up with cos x equals a half. But for me, I'm just like, okay, so secant x is hypotenuse over adjacent, so cos x would be adjacent over hypotenuse, and I can just take the reciprocal of the ratio. Okay, now I've forgotten my plus minus. Don't let me do that. Plus minus, plus minus. Okay, I got all excited about it being 2. Now, here's where you can pause the video and you can give me all the solutions between 0 and 2 pi or between 0 and 360 degrees. So hopefully you did pause and you're coming back. And so again, this is where cosine is positive or negative. So it's going to be in quadrants 1 and 4 and 2 and 3. All right, so then my adjacent is 1, my hypotenuse is 2. It's my 1, 2, root 3 triangle, which makes my reference angle pi by 3 or 60 degrees. All right, now I need to give all my solutions. So in radians, my first solution is pi by 3, then pi by 3 less than 3 pi by 3, which would be 2 pi by 3. 1 pi by 3 more than 3 pi by 3, so 4 pi by 3. And then 1 pi by 3 less than 6 pi by 3, which is 5 pi by 3. And then in degrees, my first answer is 60 degrees. 180 minus 60 is 120 degrees. 180 plus 60 is 240 degrees. And then 360 minus 60 is 300 degrees. All right, if you want to check these, what could you do? Right? We just found the angle that makes this equation true. So you could do secant squared of 60 minus 4, does that equal 0? How do you plug in secant, right? You go 1 over cos of 60, all squared, okay, minus 4, does that equal 0? All right, let's move on. All right, so here we've got another question. Now I said step number 1 was to isolate your trig function. Well, the problem here is that I have a cos squared x and a cos x. I can't isolate a trig function. So I'm going to think about, well, what kind of equation is this? Oh, it's quadratic. So to solve this, I could factor, okay? So anytime you see the squared, in fact, anytime you see something that can factor, you're going to solve by factoring. So now my new step is, step 1, I guess, would be factor, and then you could isolate your variable. So to factor this, I can notice that it is quadratic. So I'm going to do the AC method. So I'm looking for two numbers that multiply to give me -4 and add to give me 3. So I'm going to have 2 cos squared x, and then I've got plus 4 cos x minus cos x, and again, you could do this with a u substitution if you prefer, minus 2. And then I'm going to factor by grouping. Out of the first group, I can take out a 2 cos x. Out of the second group, I'm going to take out a -1. I'm going to be left with 2 cos x times cos x plus 2. And then I'm going to factor out that -1 and be left with cos x plus 2. Feeling pretty good because I got the same bracket. That's now my greatest common factor. So I'm going to greatest common factor out that cos x plus 2. And I'm left with 2 cos x minus 1, all equal to 0. So now I've set it equal to 0 and I've factored. Now I'm going to set each factor equal to 0 and solve. So I've got cos x equals -2, and I've got cos x equal to 1/2. And I need to solve them. So let's start with cos x is equal to -2. Now, anytime it's not one of your special triangles, like your 1, 2, root 3 or your 1, 1, root 2, then you are allowed to touch a calculator. If I were to touch a calculator with this one, do you know what will happen? Can I solve where cos x equals -2? Think about a graph of cos x. Okay, cos x starts up here, goes down, and goes back up here. It goes up to 1 and down to -1. How could I possibly get a value where cos x is equal to -2? I can't. Okay, so I cannot get a solution for this. There is no solution for where cos x equals -2. Now, if you didn't know that and you recognize that this isn't one of your special triangles, you are allowed to touch a calculator. So if I go inverse cos of -2, it also tells me error. And that's how I know that it's also no solution, okay? But it's outside of my range. I can't get that solution. All right. So then we're going to look at cos x equal to 1/2. Now cos x equals to 1/2, I know it's my 1, 2, root 3 triangle, so I'm going to do it. I'm going to draw a cast. Cos is positive in quadrant 1 and 4. So my adjacent is 1, my hypotenuse is 2, my 1, 2, root 3 makes my reference angle pi by 3 or 60 degrees. Hopefully you guys are starting to get good at that. So then to give my two answers, between 0 and 360, I would say that it's 60 degrees and 360 minus 60, so 300 degrees. And then between 0 and 2 pi, it would be pi by 3. And then if this is 6 pi by 3, it's 1 pi by 3 less, so 5 pi by 3. All right, moving on. If you feel ready to pause the video, feel this would be a good one to do it. What I'm going to say is, with trig, if you can't isolate your trig function, right? So if there's two coses or if there's a sine mixed in there, always set it equal to 0, factor and solve, okay? So the first thing you're going to do is subtract cos x from each side. And you end up with sine x cos x minus cos x equals 0. Okay, no option. You can't divide both sides by cos x, even though it seems like an appealing thing to do, because you're actually dividing out one of your solutions. Okay, so always, 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 step number 1, I mean, if you can't just isolate your trig function, is set it equal to 0, factor to solve. So now that I've set it equal to 0, I'm going to greatest common factor out a cos x. If I factor out a cos x, I'm left with sine x minus 1 equal to 0. And then I'm going to set each factor equal to 0. I've got cos x equals 0, and I've got sine x equals 1. So let's solve it. Where does cos x equal to 0? So as I always say for these, you can think of where cos x equals 0 using your unit circle, right? So we're thinking about, where is x equal to 0? Well, x is equal to 0 up here and down here. Or you can think of it from a graph perspective, if you're good with your graph. Cos x equals 0 here and here. Regardless, it's at 90 degrees and 270 degrees, or pi by 2 and 3 pi by 2. So my two solutions for where cos x equals 0 are 90 degrees and 270 degrees, or pi by 2 and 3 pi by 2. Okay, now let's look for all my solutions. We have to move on to sine x equal to 1. Sine x equals 1, same thing. This is not my special triangle. I always kind of get messed up with this. Tan x equal to 1 is my 1, 1 root 2, but sine x equal to 1 or cos x equal to 1 is not. So again, sine x equals 1, you can think of it as a unit circle. Now sine x is y over r, so we're thinking about where y is 1, which is only up here at 90 degrees or pi by 2. Or you can picture it as the graph. And if you picture your sine graph, it's equal to 1 here at pi by 2 or 90 degrees. Now I've already given that as part of my solution, so I don't have to state it again. So this is my solution, either 90 degrees and 270 degrees, or pi by 2 and 3 pi by 2. Okay, last one. Last one, this one is different, so don't pause the video and try this one right now. You'll notice that I went back to easy. There's only one trig function, right? It's just a cos x, so I'm not going to have to set this equal to 0 and factor to solve. Instead, I'm just going to isolate my trig function. So I'm going to subtract 3 from both sides. I end up with cos x is equal to 2.0186 minus, whoops, my calculator says error, 2.0186 minus 3, which is negative 0.9814. This is obviously not one of my special triangles, so I'm supposed to know that I can use a calculator. So you're supposed to give exact solutions where you can, And if you can't, I always express my answers in degrees to the nearest degree or in radians to the nearest 4 decimal places. So I just went and quickly checked the textbook because I was like, oh, wait a minute, this is a new textbook for me. So when it's in degrees, it wants 2 decimals actually. For any of you taking a science course, maybe they just always want 4 sig figs. Okay, so for degree, it's going to be 2 decimals. Actually, that doesn't work. And in radians, they do use 4 decimal places. Okay, so how do we do it? Well, if we were doing a special triangle, we would draw my quadrants. I'd say, okay, cos x, where is it negative? C-A-S-T. Cos is negative in quadrant 2 and quadrant 4. Now, if I were to use my calculator and say that x is equal to the inverse cos of negative 0.9814, let's try to link this to our knowledge from 7.4. The inverse cos's restricted range, I had to say that right, is always going to give an answer between 0 and pi, right? So if I plugged into my calculator the inverse cos of negative 0.9814, it's going to give me the answer in this quadrant, right? This is where my calculator will give me my answer for my negative ratio. So if I do that, so let's do it in degrees. So let's say I hit inverse cos of negative 0.9814. That gives me, to 2 decimal places, 168.93 degrees. Now, if I were going to try and get my other solution, sorry, that 3 is really bugging me. Okay, that's this answer here. This answer is 168.93 degrees, and that's what my calculator gives me. So now to figure out the other answer, because my calculator will not give me that, I would have to find my reference angle. So I don't actually ever plug in the negative. Now I could, the reference angle, I shouldn't say that, let me just do that. So the reference angle would be 180 minus 168.93. It's not that bad, okay? So if I subtract 180 from 180, I end up with 11.07 degrees as my reference angle, okay? So I had to find my reference angle. So what I could have just done is plugged in x is equal to the inverse cos of the positive ratio. And then what happens is it always gives me the reference angle. And then I could find my answer in quadrant 2 and quadrant 3. So what I'm saying with this is that when you're solving things that are equal to that negative ratio, and this is really only for cosine, because sine and tan give it to you in quadrant 4, but read in a negative direction, so it gives you the reference angle. So only for cosine. It gives you the answer in quadrant 2, so you'd have to find your reference angle. So instead of plugging in the inverse cos of negative 0.9814, I often plug in the inverse cos of positive 0.9814, because then I get that reference angle right away. But totally up to you. If you plug it into your calculator as negative, it'll give you this. Then to find the other answer, you have to find the reference angle and then put it in the 4th quadrant. Or you just find the reference angle and say, okay, 180 minus it and 180 plus it and get to your 2 answers. Regardless, okay, to answer this in degrees, my 2 answers are going to be 168.93 degrees. And then to find the other answer, I'm going to go 180 plus that reference angle, so plus 11.07, and that's going to give me 191.07 degrees. So again, totally up to you, but I am expecting both of these answers. Okay, now when we do it in radians, same thing. So I want you to pause the video right now, actually, and I would like you to get my 2 answers in radians. You can either plug in the negative ratio. So if you do that, actually, why am I saying pause the video? This one should have said 180 degrees too, sorry, because I ended up doing it degrees first. Okay, so now I'm going to do it from 0 to pi, right? If I go inverse cos of negative 0.9814, if I plug that in and I put my calculator in radians, So I'm going inverse cos of negative 0.9814. I get 2.9484. So then to find the reference angle, I would have to do 180, which is pi minus that 2.9484, or I could just find the reference angle by taking the inverse cos of the positive ratio, and that will automatically, maybe I'll say that this is reference angle, right? So if I do that, if I go inverse cos of positive 0.9814, that will give me that reference angle of 0.1932. Okay, so then if I wanted to find the other answer, I would say that the one answer is 2.9484, and the other answer I would get by saying pi plus, plus 0.1932. So I'm going to add pi to that because that's putting it in quadrant 3, and I would get 3.3348. Whew. Okay, so hopefully that wasn't too confusing. So the key thing is that when you're doing it in your calculator, you really want your reference angle, because then in this quadrant, you could say that your angle is pi minus the reference angle, or 180 degrees minus the reference angle. And then you could say in this quadrant, it's pi plus the reference angle, or 180 degrees plus the reference angle. So when it's cos, I have a tendency to plug in the inverse cos of the positive ratio. That way it works out nicer for me. All right, good luck.